So, hello everyone. Welcome to the pre-recorded video. And in this lecture, we will talk about one of the main branch of soft computing, which is artificial neural network, in short, ANN. So, the things that we will discuss in these lectures are how ANN works and uh, what is ANN, what is the mathematics behind ANN. So after this lecture, you will be a bit comfortable with background hype. Means people create some hypes that CNN is very complex, CNN is very complex. So these things, we will take a simple case and try to solve it mathematically. It is just for understanding the things. So, without delay, let's start the start the lecture. So, as I said, ANN is one of the main branch of soft computing. So, the other two branch is fuzzy inference system. That is in short, people also say it fuzzy inference system FIS, and the other is meta heuristic algorithm, which is also called as nature inspired algorithm. Nature inspired algorithm. This nature inspired algorithm is mainly used for optimization task. Optimization task. So either it is a constant optimization or a unconstrained optimization. Either it is a single objective optimization problem or multi-objective optimization problem. In all these scenarios, people nowadays it is also a trending things to use a meta-heuristic or nature-inspired algorithm to solve any of the optimization tasks that you figure out in your research. So as you can see, the name suggests ant colony optimization, particle swarm optimization, taboo search, cuckoo search, simulated annealing, lion search optimization, lion optimization. There are many algorithms. So till date, if you can figure out, I guess I have listed 200 algorithms in my recent review paper on this nature-inspired algorithm, and these 200 are original algorithms. Means if there are some certain modification of genetic algorithm, that is improved genetic algorithm or enhanced genetic algorithm, if you can count these things also, then nowadays you can say that there are more than 500 algorithms are available for optimization. So, and this optimization comes under meta heuristic, under the umbrella of meta heuristic, which is also called a nature inspired, and this is particularly biological inspired algorithm. And the most popular algorithm is your genetic algorithm. So in this lecture we will not discuss these things in detail, and we'll also not touch the fuzzy inference concept, but I will give a brief idea of these things so that you will be comfortable with the term soft computing. We will see ANN in detail, and if you have any, if you have interest, then you can come to me for fuzzy inference system and meta heuristic algorithm. So if you see ANN, then we may classify it. Means you may use ANN for two type of task. One is your classification task, and the other one is regression. Classification is a bit simpler than the regression problems that we will see. And in the regression, we have two types of regression. That one is image to value, and the other one is image to image regression. What does it mean? It means that there are two things in machine learning. One is your predictors, and one is predictant. Uh, with the help of predictors, we will try to figure out the predictant. Means if it is X, then it is Y. So in this case, we will predictors are images, and the predictants are a scalar value. But in this case, both predictors and predictants are your array, mathematical array, or we can say it is a image. So as the time process, we can I will say that nowadays fuzzy inference system is combined with ANN, and people are using these things more frequently. And the term that they have allotted to this is ANFIS. ANFIS means adaptive neuro fuzzy inference system. Adaptive neuro fuzzy inference system. So what I will suggest you to have a reading of this ANFIS and meta-heuristic algorithm in briefly, and we will see the ANN topic in detail. And one more point that I want to highlight here is fuzzy system is a perfect example of expert system. Expert system is something that if you expert system work on rule base. Means if you have written this thing that if your grade is greater than if your marks is greater than 90, then the grade is O, that is your outstanding. So this you have certain set of rules, and based upon the rule you will going to classify the newer input. This is called expert system, and the fuzzy inference system is something that is related to expert system topic. But nowadays using only FIS is absolute. Now people are using a combination of fuzzy inference system with ANN, that is ANFIS. And for ANN, we will see that if you talk about images more specifically, when we since we are in remote sensing class, so in remote sensing we have to deal with different kind of images, and the variant that we will use is your CNN, convolutional neural network. So let us proceed further and see a biological neuron. So if you can recall your 12th biology lectures, then you can say that neuron is also known as a nerve cell, and it either send or transmit or receive signals from the brain. So this is a example of a biological neuron, and let me check the change the ink. And any neuron basically consists of three parts. One part is your cell body, which is called cell body, and this cell body carries your genetical information. The second part is your axon. Axon is your tail-like structure which allow a biological neuron to transmit electrical and chemical signals. And the most important thing is your dendrites. So dendrite is the one, it is a root-like structure which receives or and process the signal from the axon of other neurons. That is, from the axon of other neurons, it either receives and process the information and transfer it to the axon of this neuron. So a neuron is biological neuron is a type of cell which doesn't reproduce or regenerate once die. So the number of neuron that we have at the time of our birth is remain constant, and it is approximately, oh sorry, it is approximately guess 100 billion neurons. There are about 100 millions 100 billions neurons in our body when we take birth. So now as we see how biological neuron performs, now let us see its counterpart, artificial neuron in a artificial neuron system. So artificial neuron is the basic building block of a artificial neural system. And if you can see this image, then you can correlate the things that the cell body is replaced with the summation. The dendrite is something that the input information multiplied with the weight, and then it gets summed up and pass it to the axon. That is your activation function in this case in the artificial neural network. So let me draw it once more for your understanding purpose. The figure is not clear, sorry for that. This is your cell body. This is your input x1, x2 up to xn, or you can say x3. A bias term is there, and this is sent to a activation function. So I have drawn the same thing. So what is the output here? It will be biased plus x1. Sorry, I have missed the weight, w1, w2, w3. So it will be x2 w2 plus x3 w3. So why we use activation function? Because the things that we will get here is a linear thing, and we have to add some non-linearity to the data so that it get easily mapped. So for that we use different kind of activation function that I will discuss as we proceed further. So let us see different uh, your yeah, this is the thing that I have discussed already, that this is the bias term. These are the inputs, these are the weights, and here we get a summation of wixi, and a simple thresholding is there that if the summation is greater than 0, then the value will be 1 or it will be -1. So in ANN we just have to remember two things. First thing is input times weight, add bias, and then activate using a activation function. So in ANN we will just remember input times the weight, add the bias term, and activate it using an activation function listed here. So if you can see, there are different types of activation function. So I have taken a screenshot from Wikipedia, and guess this, yeah, it a bit unclear that it is a soft sine. It is tan hyperbolic h, and this is your unit step signal, binary step. This is your linear thing that if y equal to x, then the plot will be linear. This is your identity. The second one is binary, that is your unit step signal, means you have a value 1 for a particular time, And the differentiation of unit function, here they have put a question mark, but the differentiation of unit step d by dt of unit step is impulse signal. Impulse signal exists only at 0, and the area, the total area from minus infinity to infinity of delta t dt is 1. So these things you might have learned if you have taken signal system courses in your UG. So I guess the things are clear. So we have discussed everything. What are the inputs? What are the weights? How we take the summation of the things, and what are the activation function? So now we have discussed both the things: biological neuron, also artificial neuron. Now let us see a step ahead. Means a higher step. Let us compare the systems. So here we can see uh, biological neural system and artificial neural system. So here are the biological neurons. These are biological neurons, and these are the things that we have learned now, which is your artificial neural. And several biological neurals are connected through synapse. The transformation of information take place, and in our case, we will connect through different layers that and a biological neural network is a combination of these connected neurons. And similarly, if you have increased the layer to multi-layer, which is called a neural network. A single layer is called perceptron, and a multi-layer is called neural network. And these are called hidden layers. And the complete nervous system is is our human brain, and here it is the complete things, that is the output input with the fully connected layers. We'll see these technical terms as we proceed further. So now let us start the mathematical things. Uh, so to learn the ENN, what we do, we use gradient descent and delta rule algorithm. So in any you might have faced some courses related to machine learning or ANN. So you may have encountered three terms, or if you haven't, then you will. The first term is gradient descent. The second term is your delta rule, and the third thing is back propagation. Gradient descent is nothing but finding a minima. So you will go in a direction of the steepest descent. Means we will always look for a minimum. Delta rule is nothing but updation rule. Means if we have what I can say, if we have a weight value W, then delta rule will suggest that the updated weight value will be Wi plus delta Wi. This is nothing, this is the complete thing that what delta rule suggests. It is just updating the value of a variable. In our case, we have weighting coefficient as a variable. So these are the things that we will compute in our in this lecture, or these values are has been computed by any neural network. So gradient descent is something that finding minima. Delta rule is something to update the current variable or the variable that needs to be known by the algorithm. So to understand these two things, we have selected a perceptron, that is a single layer neural network, and we have eliminated the activation part. So to make it very simple, so you can see here we have a bias term, several inputs with a weighting coefficient, and we will try to train this network. So before training that, we have to uh, we have to select performance matrices. Means while training, we will simultaneously try to measure the errors that means our system means the errors present in the system, and we will try to minimize these errors. So for that, we have to select some optimization function, and in our case what we have selected is your mean square error function. Mean square error, or you can select the RMC also. So for the sake of simplicity, means we are not interested in evaluating the square root of this part. Means if you take the square root of these things, then it will known as RMSE. So for the sake of simplicity, we will we have considered the mean square error as the optimization part to evaluate the error while training your perceptron. So as we proceed further, so the gradient descent rule, uh, we have learned some gradient filters in while Gaurav sir have discussed you the filtering topic, gradient filter or Laplacian filter. So in discrete domain, gradient is nothing but a differentiation, first order difference, and the Laplacian is second order difference. Once in continuous, you can say second order derivative. So as the name suggests, gradient. So we will have to take differentiation of the mean square error function. Mean square error function. So we will see the differentiation. Differentiation part in the next slide. Before going through that, let us see the delta rule, which is nothing but updating the value of W. That is, W will be initial W plus the change in the W. That is a weighting coefficient, and that change, this part is sorry. This part is given by negative of zeta and the gradient of E. So where eta is your learning rate. So we have to deal with this equation only while training a perceptron. So let us compute the gradient of E, which is nothing but d by dw of the mean square function. Uh, we will take out the 1 by 2 as its constant and differentiate these things. So this is something that differentiating d by dx of x square. So we will get these things. After that, uh, it is the output, and the output, what we have seen, what is the output? Output is wixi. So we have just substituted this wixi is come from this part. Let me show you to avoid any this part. So once we substitute these things, so it will come it will become a function of W, and t is independent of W, so it will be 0, and this will be become minus xi. So the updated equation will be the updated, let me rewrite this part. The updated equation will be minus of summation desired, and O is the output into the xi part. So if you can let us first write it has already been written that we need to use this equation wi equal to initial wi plus delta wi, and that delta wi is given by this. Here we have just substituted the gradient of E. So let us start the things. Uh, Before going through, let us see different types of NN that are present. So there exist several different kinds of ANN, and you can see feed forward neural network, radial basis function neural network, coherent self-organizing NN, recurrent NN, and convolutional neural network, modular neural network. So in our course, what we are interested in learning the CNN, and we will not touch any other types of neural network, and we will discuss briefly the CNN at the end of this lecture. And in the next video, I will share a practical implementation of CNN with a proper explanation. So as the we can see, there may exist higher numbers of layer. So this is very interesting point. Means if someone says uh, why we increase the hidden layer, and what are the means what are the physical significance of these things. So you need to just say that the layers that are closer to the inputs represent the low level features, and such as your edges, detecting the edges and gradient, while the layer those which are closer to the outputs, and those layer are high level features, and they will uh, means recognize the your object or a part of a image. So in this is the practical case. This hidden layer is closer to the input, so it will extract the low level features like edges, boundaries. And since this hidden layer is close to the output, it will extract the high level features. What these things mean, let us see this in the next slide. That the initial layer learn low features, that is edges, textures, and colors, and the deeper layers that are present near to the output, that learn the face boundaries, like these things, faces, bodies, words, and label. So now the question is, how many hidden layers? So one may ask that how many hidden layers are required. So you can say that increasing the hidden, you may increase your hidden layer, and increasing the hidden layer may or may not increase your accuracy. But unnecessary increase in hidden layer will end up with means it will, what it will cause, it will end up learning more number of parameters than actually needed to solve your problem. So we need to put that much hidden layer which exactly learn the things that are necessary to solve your objectives. That's it. So we need that much hidden layer which actually learn the things that are required to solve your problem. So now the question arises that how you will decide how much hidden layer will solve your problem. So for that, either you can go for a try and error method, or go for a meta heuristic optimization techniques. So now let us proceed further and see the ANN inside of the ANN. So there are several debates over the use of ANN, that why people use ANN, and because it is considered as a black box. So we don't exactly interpret the things that the ANN do internally. So are ANN not a black box, or it is a black box? So let us find this answer by actually training a ANN. And these are the steps for training the ANN, that initially we guess the weight of the neuron, bias value, learning rate, and a target output, and select one of the activation function for efficient learning. And second part is that calculate the observed output, that is your OD, using the guess value of the weight and the bias. Weight is your WI. Calculate the residual error by using the object mean square error optimization function, and calculate the weight change by back propagation, which is known as correcting the weight values, and update the weights. Again, calculate the observed value based on the updated weight till the difference. Repeat the above process until the residual error becomes zero. Ideally, means you have to just it is close to zero. So let us start the training a neural network. So as you can see in this diagram, we have input x1, x2. We have weight w11, sorry, v11, v22, v21, v12, w and this is a one hidden layer. This is input, this is output. So this is the weight with the input, this is the weight with the output. So we have represented it in w11, w21, w12, and w22. So we have initialized this weights value, and all the bias are set to 1, means the bias thing is 1. And also we will not draw them for clarity. Yes, if we as we proceed further, the things will get complicated. So for the sake of simplicity and ease of understanding, we will just avoid drawing the this bias term. We will consider this mathematically, but we will not draw this. And we will assume a learning rate of 0.1, and let us assume input 0 and 1, means x1 is 0, x2 is 1. For this set of input 0, 1, and this set of weight coefficient, we are expecting a value of, sorry, we are expecting a value of 1 and 0. So let us start. So with 0 and 1, and with this weighting coefficient and the bias terms, we will compute y1 and y2, and expecting it to be closer than y1 to be 1 and y2 to be 0. So let us start. You can see we have to first evaluate u1 and u2. So what will be u1? U1 will be bias plus x1 v1 plus x2 v12, and similarly u2 will be bias plus x1 v21 plus x2 v22. So u1 will be x1 multiplied v1 1, and x2 multiplied with v12 plus the bias term. Okay, so we have considered the bias to 1, and if you solve this, you will get u1 to 1 and u2 be 2. Now we have the value u1 and u2, means we have value at this hidden layers. So let us proceed further. What we assume? We assume that u1 is just zeta 1 and u2 is zeta 2, that is z1 and z2, and through this value we will compute y1 and y2. So what will be the value of y1? If we can write a equation for y1, that is bias plus z1 w11 plus z2 w12, and for y2 it will be again adding the bias term plus zeta 1 zeta 21 plus zeta 2 zeta 22. Okay, now if we can put these values, we will get a value of y1 equal to 2 and y2 equal to 2. So what we are expecting? We are expecting y1 to become 1 and y2 become 0, but we are getting a value of 2 2. So here we will compute the error, and the error is desired minus the output. So for you can subtract these things, means desired is 1 minus the value that we have obtained. Again, this is called delta 1 and this is delta 2. It is 0 minus 2, so it is delta 1 and this is delta 2. So after computing delta 1 and delta 2, let us proceed further to update the weight. So since we have computed a delta at the output, so through that delta, we will try to update the W11, W21, W12, and W22. So for updating the weight, let me write the formula. The only tricky thing that you will face in NN is writing the formula for the updating the weights. So it is something it's similar to what we have discussed, that uh, new weight is just initial weight plus eta of, sorry, it is gradient of E. So we will just write the same thing, that W11, that is the new weight, W11 dash will be equal to the initial W11 plus eta TD minus OD, desired minus the output, into Z1. Okay, since we are getting the values through backward, that's why this Z1 comes into play. So if you see, this value is nothing but your, for W11 it is delta 1. So similarly we can write a formula for W21 dash, which is W21 plus eta delta 2 Z2. W12 will be W12 will be initial W12 plus zeta, and for W12 it will be zeta 1, delta 1 and Z2. And similarly, for W22 initial weight plus eta delta 2 Z2. So let me check once. W21. For W21, we have initial value of W21 plus eta delta 2 Z1. It is Z1. Sorry for the mistake. Because we will get two zeta one term and two zeta two terms. So if you we know the zeta is 0.1, we know the initial values, and we know delta 1 delta 2, we know z1 z2. So when we substitute these values, we will get the updated weights between the hidden layer and the output layer. So similarly, we will as we proceed further, let me go there. So yeah, a clean diagram. So we have updated this weight, and what we have to compute, we have to compute the changes at the hidden layer. Earlier we have computed the changes delta 1 delta 2 at the output layer. Now we will have to compute the changes at the hidden layer itself, which we have represented in a small delta. And here I have written the formula. It is nothing, delta 1 will be nothing but this weight multiplied with delta 1, this weight multiplied with delta 2. And again, once we compute the delta 1 and delta 2, we will update these weighting values, which is the weighting values between the input layer and the hidden layer. And similarly to the previous case, we can write the values. It is nothing but V11 will be initial value of V11 plus learning rate delta 1 x1. In the previous case, we are taking the value z1 here, and since it is from the input layer, so we will put x1. And similarly, for v21, we will have v21 initial value of v21 learning rate delta 2 x1. And for v12, the updated value will be, sorry, v12 plus learning rate delta 1 x2. And similarly, v22 will be initial value of v22 eta delta 2 x2. Let me check. Yeah, so you can put these things, you know everything, you know delta 1 delta 2, yeah, you know small delta 1 and small delta 2. Just put the things and you will get the updated values of the weighting coefficient between the input layer and the hidden layer. So we have updated the things. So let me summarize the thing. What we have, where we have started with a value x1 equal to 0, x2 equal to 1, and some initial guess of the weights of v and w. And with that, we obtained output y1 2 and y2 2. We have measured the errors and updated the weights. We have updated v, we have updated w set, v set. Now once we update v and w, let's repeat the process. and see how close we are going uh, to our desired output. Our desired output is y1 should be 1 and y2 should be 0. So let us repeat the thing. So once you repeat the things, you will get to know that y1 will be 1.66 and y2 will be 0.33. So it is something closer to 1, and this is something closer to 0. So from 2 it get to 1.66, sorry, from 2 it get to 1.66, and from 2 it get reduced to 0.33. So this is the way through which we keep on updating the weights based upon the error that we have at the output layer. So now I would like to ask the same question: is it a black box, or you have understood the things? So it seems that now ANN is not a black box, but what I would like to add this thing, because since we have selected a simplest case of a ANN, where we have only one hidden layer, and we don't use activation function, any activation function. So this in real life, the means the network that we design, or the existing pre-trained network that are available in the open market are far more complex than what we are learning here. So it is a black box, because as the number of layer and the number of activation function and different things, we will see what are the other different things are there. As things increases, the complexity get increased. So a simple case of Google Net, it is a pre-trained network available by Google. So you can see how many hidden layers are there, and based upon we have 22 hidden layer, and it provide an accuracy of 66. So you can check on internet that there are different it is visible or not, I don't know. Let me write it. It is AlexNet, it is VGG Sol 16, it is VGG 19. So similarly we have different pre-trained network that are available in the market, and the depth represent the number of your uh, hidden layers. As we can see, 22 for Google Net, and this is the corresponding spatial complexity, means the size it requires. So, and you can see the corresponding accuracy curve also. Yeah, I have put in that. This is the computational time required in a CUBA, that is your GPU, and this is the accuracy. So you can see Google Net have a higher accuracy than AlexNet, and nowadays we have some higher accuracy. We can have reached accuracy of approximately, I guess, 80. So these are the network that are pre-trained network, and these are mainly for object detection. If you use these networks, then if you are using a webcam, then you can bring the things that you can bring your laptop in front of it, you can put your water bottle in front of it, so it will detect and show you the percentage that with 90% it is a bottle, or it is 70% it is a mouse or a keyboard. That is the object detection thing. So but as we know that these things are not useful for us, since we are remote sensing guy. So for us, we have to create our own network. So the main challenging task in ANN or CNN is that we have to create our own pre-trained network based upon our objective, and after that we have to evaluate this network and customize this to have a higher accuracy. So these two things are challenging. So in the next lecture, we will see how to train our own pre-trained network, and we will see a detail of convolutional neural network. So I will just briefly discuss the things in this lecture, that what is CNN. So if you can see, let me separate it into different part. We have learned these things now. We have learned the fully connected layer. Means if you have discrete set of values, then how it get up, how it will update the weights. Okay. So the extra thing that remain to be learned is this part. That is your feature extraction part. And let me simplify it further. It is nothing. It is nothing but the input data set. Means we have inputs, images that we have, and the second part is convolution followed by a non-linearity layer, that is ReLU, which is rectified linear unit. So as I have said that there requires some non-linearity to be added, and since convolution is a linear operation, so after a linear operation we put a non-linear layer, that is rectified linear unit, and then we apply pooling. Pooling is something that summarizes the things. Uh, Let me take an example, then it will be more clear to you. Suppose we have a matrix of it 1, 2, 6, 7, 8, 2, 1, 3, 5, 4, 9, 11. Any value 0, 3, 7, 30. So it is a 4 cross 4 matrix. What pooling will do, it will extract the summary. So the different types of pooling that is available in the market is average pooling or maximum pooling. But out of these things, maximum pooling is very reliable and it is used extensively from the last 2 years or 3 years. Maximum pooling is among the favorite pooling algorithm that people use. So what it will do when we apply max pooling, so it will reduce it into 2 cross 2 matrix. So what it will do, it will first take this into consideration, and maximum pooling will take a maximum of this 4 value, which is 8. Again it will select this and take a maximum of this, which is I guess 7. After that it will select this and take a maximum value, which is the maximum 5 is the maximum value, and at last it will take this matrix and take a maximum of this value, which is 13. So it just summarizes this 4 cross 4 matrix by just 2 cross 2. So why we do pooling? Because in some sense you can say that we are losing some set of information. Yes, we are losing some set of information, but if you can't apply, if you not apply pooling, then what you have to do, you have to pay for spatial computation. Means if you have a GPU, then you have to pay for a processing on time basis. And if you have a complex model, or if you have a higher complex with respect to time, with respect to space complexity, then people will not use your model. So for that we apply pooling. So let me summarize the thing that after convolution is nothing but filtering. For edges, we will use high pass filter followed by a non-linear term to add the non-linearity and pooling. So this step we will repeat these steps till we have sufficient features extraction, and we have repeated this thing thrice, and after that we have used a flatter layer which will nothing which will do nothing just to convert sorry convert an array, suppose n cross n array, into a vector, a row or column vector of dimension 1 cross n into n. Okay, so we will see in the next lecture. Yeah, one more thing that I want to discuss. Once we created this layer, and once we connected a fully connected layer, after that we will have two more layer, that is one is softmax and the other one is your I guess classification layer in the practical implementation. And it will since here only three classes, so it will assign a score. Suppose it is saying 0.2 horse. If you convert it into percentage, then this this network is suggesting that it is 20% horse, 0.7% zebra, sorry, 70% zebra, 70% zebra, and 10% dog. So we here we apply a maximum function and select that it is a zebra, which is a zebra. So in the next lecture we will see how we will design a convolutional neural network in MATLAB. So I would like to request you to just make sure that you have a MATLAB installed in your system, and we will see classification task, and I will also give you a glimpse of how we can apply regression problem. So that's all for this lecture, and let us see you in the practical implementation lecture. So see you then, bye.